Good morning or good afternoon, guys. So today is day 2 of solving linear systems review. All of today's notes are going to be done on a lined piece of paper. So you're going to either need to take out a piece of paper from your own notebook to put in your binder, or on my back bookshelf, you know I have lined paper there that you can grab to go ahead and take today's notes. So they are on paper, does not go on along with the handout. All right, so we're going to learn a second way to solve a system. And the reason why we need to do this is sometimes you don't have to write this down. When you have two lines that intersect, they might not intersect at whole integer values. And we don't want to estimate what that point is using fractions or decimals. We want to find the exact answer. So because of this, the fact that lines don't always intersect at whole numbers, we need other ways to solve systems algebraically that we're going to learn and review today. So the second method is called the substitution method. So we're going to be solving using the substitution method. Okay, and this is day 2 of the solving section. This is a 6-day section, and then the second section of the unit is all real-world practice. So the way the substitution works, there's 3 steps to it. Step 1 is you're going to isolate a variable. Any variable you want to, but I'll talk to you about strategies today about how to pick the variable that's easiest to isolate. So you're going to have to isolate a variable. Step 2, whatever variable you isolated, say y, you're going to substitute that equation in for the y in the other equation. So you're going to substitute one equation into the other and solve. This is going to be very similar to what we were doing when we did composition, when we composed functions and subbed one function into another function. It's that similar idea here. Once you do step 2, you're going to have one answer. You're either going to have what x equals or what y equals. So step 3, you have to substitute, missing an I there. I should say oh my goodness, I can't spell. What am I doing? Sorry, guys. That answer that you got in step 2 into any equation you want and solve for the other variable. Okay. I call this the ISS method, which kind of doesn't really sound so good. Not in school suspension, but it's isolate, substitute, substitute again. ISS, isolate, substitute, substitute again. So we are going to try 5 examples of this. Everything that I write down, you guys are writing down. These are all notes on how to solve using the substitution method. Remember, when you're solving, even though we don't have a graph to look at, we're still finding the point at which these 2 lines would intersect one another. Here's our first example. Y minus x equals -4, and y equals -x plus 2. So step number 1 said to isolate a variable. In this case, step number 1 is done for us. I'm going to rewrite the equation that already has a variable isolated. Okay, so y was already isolated. Step number 2, I'm going to change colors here, says substitute that equation into the other equation. Because the y is isolated, we're going to take what y equals and put it into y in the other equation. If you isolated x, you would sub it in for x. You're going to see that we don't always isolate y like we did last unit. Just whatever variable is easier to isolate. because the y was already isolated, I'm going to take what y equals, which is negative x plus 2, and replace it with the in the other equation where y is. So let's look at that top equation. Y minus x minus equals negative 4. Instead of writing this first y, I'm going to write the other equation, which is negative x plus 2. Then I still have this minus x term, and it's still equal to negative 4. Okay. So this negative x plus 2 was originally a y variable, but I know what y equals. Y equals negative x plus 2, so I replaced it. I'm going to combine my like terms. I have a negative x and another negative 1x to get negative 2x plus 2 equals negative 4. I'm going to subtract the 2 to the other side, and I'm isolating and solving for x right now. And if I divide both sides by negative 2, then I'm going to go ahead and get positive 3 for an answer. That's only one coordinate, though. I need an x and a y. So the third step is substitute again. It's isolate, substitute, substitute. So we're supposed to take the x equals 3 and substitute that into one of the original equations for x, because we solved for x. I'm going to sub it in to the second equation. Reason being is if I already have x, I'm trying to find y, and the y is already isolated in that equation. So step 3, I'm going to have y equals negative, then I'm subbing in 3 plus 2, and negative 3 plus 2 is negative 1. So my solution is going to be 3 comma negative 1. I isolated, substitute, substitute again. I'm going to do 4 more of those practice problems. And at any point, if we're going too fast, pause the video, take the notes. So here's example number 2. New system. X equals y minus 1, and 2x plus y equals negative 2. So step 1 in ISS is to isolate. Luckily, it's already done again for us. We already have an equation with a variable isolated, which is equation number 1. The x variable is isolated. I'm just going to rewrite that equation. Step number 2, I'm supposed to substitute. So I take my isolated equation, and I take what x equals, which is y minus 1. So I don't have x equals number, I have x equals an expression. And I have to take that and put it into the other equation, and this time I'm subbing it in for x, because the x was the one that's isolated. So for step 2, I'm going to have 2 times, then we're replacing this x right here with y minus 1. I'm putting it in parentheses because the x had a coefficient. And then I still have my plus y, and it's still equal to negative 2. Combine like terms, and this time we're solving for y. Once you do step 2 and you sub the equation in, you should only have one variable. If you still have x's and y's, you did something wrong. I will get 2y minus 2 plus y equals negative 2. All I did is just distribute. Combine like terms, and solve that 2-step equation. Add over the 2. 3y is going to end up being 0. And when I divide by 3, 0 divided by 3 is 0. 0 is a number. Don't freak out if you get 0. We are ready for our third step, which is substitute again. So I found y. I have to substitute that y value into one of my equations. I'm going to substitute it into the original equation for y, since I'm trying to find x and the x is already isolated. So x will equal 0 minus 1, and x will equal negative 1. So my solution is an ordered pair x comma y. X always goes first. So it's going to be negative 1 comma 0. that would be where they would intersect graphically if I were to graph these. Okay. Pause if you need to. Take another minute, finish copying down the notes, and then I'm going to keep going on with the lesson. Ready for example number 3? Y plus 3x equals 4, and 5x plus 2y equals 2. Step 1, isolate a variable. This time that's not done already for us. We have to pick a variable that's easiest to isolate. When I do that, I like to look to see if any variable has a coefficient of 1 or negative 1. Those are the easiest variables to isolate. This top one does. Okay, we have a y with a coefficient of 1, so I'm going to rewrite that. And we're going to go ahead and isolate y by subtracting over the 3x. So we actually have to do work for step 1 this time. But now my y is isolated. Step 2, substitute. So we're going to take what y equaled, that was the variable we isolated, and we substitute it into the other equation. And because we isolated y, it's going in for y. 5x plus 2 times negative 3x plus 4 equals 2. Only x's, so that's a hint that we probably did it right. We're going to distribute the 2. 5x, positive 2 times negative 3x is negative 6x, and positive 2 times positive 4 is positive 8. Combine like terms. And keep solving. I'm going to subtract my 8. And it's almost done, but x has a negative coefficient. I can't have that. So we're going to divide both sides by negative 1. And x comes out to be positive 6. Step 3, we're going to take what x equals and go ahead and sub that into one of the original equations to find y. I'm going to sub it into this top equation for x because the y looks easier to solve for there. So for step 3, y plus 3 times 6, I'm subbing it in for x because this is an x value, equals 4. Y plus 18 equals 4. If I subtract the 18, I'm going to get y equals negative 14. So my solution is 6 comma negative 14. Two more examples for today, and if there's any other time left over, you guys can start your homework. So pause if you need to. I'm going to continue on. Number 4, using substitution. Isolate, substitute, substitute. I know these are long problems. However, this is all learned in Algebra 1. There should be nothing new right now. You learned this last year from your Algebra 1 teachers. We're just trying to review it to remember it. That way we can apply it to some more challenging real-world scenarios. Okay. So here we go. We're going to go ahead and solve y equals x minus 1 and y equals negative 5x minus 3. Oh, sorry, not 3, 13. 13. Not 0.13. Now it looks like 0.13. All right. So for step 1, isolate. They already are both isolated. I personally think these are the easiest of all of them when the y values are both isolated in both equations. I'm going to jump right to step 2. Step 2 is substitute. So we're going to take what y equals and sub it in for the y in the other equation. Again, if you isolate y, you sub it in for y. For these problems, when the y's are both isolated, what you're really doing is just setting the two equations equal to each other. So you will end up with x minus 1 equals negative 5x minus 13. Okay, they're set equal to each other. This is the first time we've been solving this year where we have x's on both sides of the equation. Whenever you move it across the equal sign, you have to do opposite operations. And you move x's before constant terms. So I'm going to add over, why did I write 6? Sorry about that. I'm going to add over the 5x to both sides, which will give me 6x minus 1 equals negative 13. And you solve it like a normal two-step equation. Add over the 1, careful with your signs. Negative 13 plus 1 is negative 12. And if you divide both sides by 6, x will equal negative 2. Step 3 is still the same thing. Substitute again. Take your x value, put it into either or. I'm going to put it into this top one. Y will equal negative 2 minus 1. So y equals negative 3. And our solution becomes negative 2 comma negative 3. Okay. One last example, and then I just have one other comment to make. It's not an actual example, though. So example number 5. We're going to have negative 6x plus 2y equals 4. And negative 9x plus 3y equals 12. This is probably going to be the hardest of them all. Step 1 in ISS is isolate. We have no variables with a coefficient of 1. So the other option, when you're trying to figure out what variable to isolate, is ask yourself, will that coefficient go into the other numbers? So for example, does 6 go into 2 and 4? No, it doesn't. So I'm not going to go ahead and isolate that. I'm just going to pause real quick. All right, sorry guys, I just had to pause real quick because I had a visitor. So what I was saying is when you're trying to decide which variable to isolate, you need to ask yourself, does 6 go into 2 or 4? No, it doesn't. So don't isolate x. Does 9 go into 3 and 12? No, it doesn't. So don't isolate x. Then you could ask yourself, does 2 go into 6 and 4? Yes, it does. So y would be a good variable. And then below it, does 3 go into 9 and 12? Yes, it does. So I would say isolate the y in either or. You don't have to do both. You just have to technically isolate one equation. So I'm going to pick the top equation, and we're going to isolate the y. So we're going to add over the 6x. 2y will equal 6x plus 4. And divide everything by 2. So y will equal 3x plus 2. Step 1 is done. We have isolated. Step 2, substitute. So we're going to substitute the 3x plus 2 into the other equation for y. Okay, so step 2, we are substituting right now. So we will have negative 9x plus 3 times 3x plus 2. And that's going to equal 12. Distribute. We're going to get 9x plus 6 equals 12. When I combine my terms, my x's are gone. They have disappeared. I have no x. And I am left with 6 equals 12. I have no variable. This is going to be one of those special solutions that you learned about yesterday, either the no solution or the infinitely many. This is a false statement. 6 does not equal 12. Therefore, this problem would have no solution. The lines would be parallel if you graphed them. We don't have time to do any others today, but just for example, for reference, let's call this number 6. Say at the end, you were solving, and the variables canceled out again, and you were left with 6 equals 6. That's a true statement. When 6 does equal 6 and your variables cancel out, that's when you would have infinitely many solutions. So when solving algebraically, if your variables cancel, they're gone to 0x or 0y, that's when you're going to have one of the special cases, either no solution or infinitely many. If there is any class time left right now, you guys are going to start your homeworks. There is an answer key on there that you can use to check to see if you're doing it right on the back. And tomorrow you guys are going to do a practice type 3 on graphing and the substitution method, this idea of isolate, substitute, substitute, ISS. Just make sure when you're isolating a variable, whatever variable you isolated, you take that expression and sub it into the other equation for the variable you isolated. You isolate y, you sub it in for y. You isolate x, you sub it in for x. And that's it, guys. See you later.